1.
That becomes 3/10.
Oh yeah, because 6 over 20. We could reduce that, huh? Right, 6 over 5 times 4, 6 over 20. We could reduce that to be 3/10.
Mm-hmm.
Right, everyone? And then you get u to the 5/6
Let's see.
plus c. Now, don't forget, this was an indefinite integral. Amber didn't have numbers. I got to put the resubstitute, right?
Yeah.
And I have to put the plus c. What was u?
1 plus 2, 4.
So here's the answer. 3/10 parentheses 1 plus t to the 4th raised to the 5/6 power plus c. You could check this by differentiating it if you wanted to.
Can you show some IBP, integration by product?
Oh, heck yeah, I'll show you that.
Okay.
I gotta show you that, everyone. I gotta show you that one. Oh, go ahead.
Where did you get the 5/6?
So once the hard work was over here. So integral 1/4 integral u to the negative 1/6 to u. Now we're gonna do the antiderivative. You know the rule. You pump it up by one integer, divide by the number. But what's negative 1/6 add 1? Oh, common denominators. Negative 1/6 plus 6/6 makes it 5/6. And then we gotta divide by it. There you go. Hey, if you have to, students sometimes pull out the calculator. What the heck is negative 1/6 plus 1? They frack it, you know? Just to make sure. You can do that. Isn't it weird? So, alright, I'm going to show you that one, but I got a new one.
Okay.
And when we, in this class, know how to take the integral of sine, don't we? We know how to do the integral of cosine, don't we?
Mm-hmm.
Yes, you do. What about this guy? Some of you might say secant squared. That's what I did in my, I remember I was a student, I screwed up and did that. Wrong. I had it backwards. Knowing the derivative of tangent is what? Secant squared, so the integral of tangent, not secant squared. We haven't seen this yet. I
Okay.
haven't shown it to you yet, but we can do it now. But we gotta put our thinking caps on, okay?
Mm-hmm.
So when we're gonna put our thinking caps on, all right? Now don't forget, let me put something over here. What's the integral of 1 over x?
Natural log of absolute value of x.
Natural log, you gotta put an absolute value of what?
X.
Is that what agree?
Mm-hmm.
Don't forget that. What's the integral of 1 over x? Natural log of x plus c, true? Let's have some fun. This is the first time we're doing this. So this is fun, everyone. We're finding the antiderivative of tangent x. We haven't done that yet. Believe it or not, it involves a u sub. Yep.
Oh, so that
We
should-
gotta put our thinking caps on here, because look. I mean, I got my u ready. I've got my du ready. Everyone, we're looking at this going, what the heck? What, are you gonna let u equal tangent? You're gonna go nowhere, right? Okay, maybe I'll let u equal x. We're gonna go nowhere with that. And what's the derivative of x? 1. Yeah, that's not gonna work. But we're gonna get this. We just need to back up and remember a very important trig identity. Who? Raise your hand. Who knows a very, I call it a 5-star trig identity. A trig identity for tangent of x. What do you guess?
Hi.
Sine
Sine over cosine. That's going to get us through this problem. You know why? What's the derivative of sine?
Cosine.
Cosine. Or if you want, you know, what's the derivative of cosine? Sine. So here we go. To get this problem rocking and rolling with the what? Substitution rule? We know we got to get something to kind of cancel out when we do this. And substitute. We're going to start out by saying this is the same as. We use the trig identity. But there's no other way to do this problem. That's how we got to do it, right? That's why that trig identity is so important to know. We got to know that one. By the way, who has one for cotangent of x? Cosine over what?
Sine.
That's what you do. You do the same thing. Now, this, don't get upset. Don't get upset, everyone in here. If you try this and you screwed up at first. Because right now you might think you have an option, but we don't. We're going to let u equal to sine or cosine. One of them works, the other one doesn't work. So don't get worried if you try it and what? Doesn't work. So maybe on purpose I should try the one that doesn't work. I want to show it to you. Watch this. Ready? This would not work. I want you to see why. Let me get my set, even this isn't going to work. You why? It looks like it. Sine and cos. Well, what's the derivative?
Cosine x, yeah, you don't know what.
Okay, now watch this. Go substitute. No constants, right, Josephine? I want you to see why this doesn't work. There's no constant here, is there? Right? Alright, so now I get ready to substitute. Well, the U will replace the what? The sign, right? Oh, cool, cool, alright, you're gonna be U, but sorry. It doesn't match up. Du must equal what?
1 over x.
Cosine dx, dx is not the same as 1 over cosine dx. You see what I'm saying?
Mm-hmm.
Well, no worries. Change this upside down frown to a happy face. I'm gonna try and let u equal what? What's my other option? Cosine. Oh, it'll work now. So just remember that. Do not fear when you try and it doesn't work. Just scratch it out. Just go, here, let me let u equal the other one. I've done it many times. Oh, whoops. So let u equal cosine x. Now what's that? Be careful. Because we keep doing antiderivatives and derivatives, we get confused. We need this. True? What's the derivative?
Negative sine x.
Is it negative or positive? Look, we're doing derivative over here. When we go off to the side, we do derivative. Derivative of cosine of x is
Negative sine
negative sine of x
dx.
dx. Josephine, a negative popped up. So that's a constant, isn't it really? Right? Isn't it? Negative 1? So what can I do? I can divide a what on both sides?
Negative 1.
Well, this looks silly when if I divide a negative 1. So are you okay if I just write it as negative du?
Mm-hmm.
So here, I'm going to write this. Negative du is equivalent to the what?
Sine x dx.
Let me box these. This is going to work. This is going to work. Let me get this up again. Keep in mind this would work for cotangent as well. What about secant and cosecant? Wait till Calc 2. Don't worry, we don't give you those. Alright, let's go in here. What you replacing? Ooh, down here. Look at this, everyone down here. Right? U's down there now. Now, what's this negative d replace? Yeah, it's going to replace the entire sine of x dx, right? There we go. Cross out this and put down what? Now, when don't forget my little negative, right? Where can I put the negative? See, that's what happened. The negative just stayed up front. Now, look carefully at that. That's not negative integral of u. What's in the numerator?
1 over u.
Everyone see that?
Mm-hmm.
Right? Now we're over here. What's the integral of 1 over x?
So negative
Natural log of what?
u.
X, right? Negative.
Natural
Log. Here we go. Natural log.
cosine x.
Now, if you want to be fancy, does anybody know a rule? There's only 3 log properties where you can move this to the power.
Mm-hmm.
Did you know that? Did you know you're allowed to do that? So I should put in more here. This is for all you nifty, your log properties. I could write this as ln of cosine of x to what power?
Negative 1.
Now, at cosine of x to the negative 1, that doesn't mean inverse cosine, it means 1 over cosine. What is 1 over cosine? What's 1 over cosine? That's not inverse cosine, that's just...
Secant.
Yeah, that's 1 over cosine. So, if you want to be cool, you can write this like that. Do you have to, though? No, this is fine. This is fine. Don't think you got to do that. All right? That's totally fine. But if you want it, if you notice, you can put that negative and kind of move it up here. Just keep the bars around it, right? People get confused, though. They think that's the actual antiderivative. What do y'all think of the U stuff, though?
Excellent.
Guess what we're doing tomorrow? More of these. This is like related rates. It's the one class I like to spend. I like to spend 2 classes on what? Substitutional. I am telling you, it's the main rule used in Calc 2 and Calc 3 for anti-differentiation. Okay? And I get students all the time, especially down at the Naval Academy, I'll have to edit that, but I get them, Calc 3, they can't do U subs. And I'm like, first day, I'm like, okay, let's review U subs. Do this a couple times. Doing a great job. Have a super day, and Art, before you leave, I'm going to show you what?
IBP? Okay.
Cool. Kayla, you like this stuff? Oh, cool. quality like this? You do?
That's why I smiled. You take the derivative of either 2x.
See you, man.
Good call. Good logic.
Tomorrow we'll go over more of these.
A bunch more.
And then Thursday,
You got it. Does that work?
and then Monday we'll do the final, and then Tuesday either do it Wednesday or Thursday.
You nailed it. And don't hesitate. If this Thursday, if you feel pretty much confident with the entire reading, you just want to ask a question about something, that's great. I'll do it.
See you, ladies. Bye.
Okay,
I'm serious.
so just like go ahead and ask.
Final exams are weighted more than tests. And you might just say, hey, Thursday, I'm ready for this. I'm gonna ask about that.
See ya. Have fun.
Okay? Josephine, so feel free to do
Whichever
that.
you do.
Tuesday, we gotta review that. But hey, if you're, because I think a lot of you are gonna start
Yeah,
prepping
just
over
this one, one to pull for, that will be easy.
On Thursday, do I have to come in on Wednesday?
Yeah? Because a lot of people like to study on their own.
When you guys come to the, like, chapter 7, right, let me know. I can help you out.
More use of
Those
it.
are difficult.
It's a good day to miss.
Who's it?
More and more use of it.
Chapter 5 is,
Get notes.
Yeah, I'll get the notes.
Chapter 6 is what, quantum mechanics, little quantum mechanics, chapter
In
7.
the morning for Connor.
What are you talking
I
about?
know.
Not 141, Reba. Reba, the one that was wearing orange this morning.
What's that?
Reba,
Ariba?
that's my sister.
I gotta remember
She
this.
wasn't gonna tell you.
How did I
that.
not know? Is her last name
They
B-U-T-T?
have two different last names.
Oh, thank you. Because I would have caught that.
Yeah, no one can get that.
Ariba. All right, I gotta make sure, because I just started teaching them, so I don't have the names down yet. Does she like it, or is it boring?
No, she likes it.
Oh.
I told her you were a good professor.
Oh,
but
thanks.
she was like, she likes the class.
Oh, cool.
Yeah. She started doing practice problems and I was just watching her while I'm math right in front of me.
All right, Ariba, right?
Yeah, Reba.
It's your sister.
Yep,
Cool. Thanks.
thank you.
We're here to learn the new method you were talking about.
You too?
Yeah, let's go.
Where's Art? Art, you gonna watch?
Yeah,
They wanna see it too.
I'll record it too.
Alright, Art. You gotta come up here with us.
Hey, you know what we gotta do first though?
What?
Can we prove it?
Sure.
Oh, he's gonna get on camera. We're gonna prove this thing first. Now let's,
You probably wanna stand here with the camera.
let's say M is F times G, right?
Mm-hmm.
Now, what's the derivative of that?
F prime
What's G?
G, the F prime
What
G.
am I doing?
F
The
prime,
entire.
F
First-
prime times G,
First time to the second.
yeah, plus G times F prime.
G.
I'm gonna point out that when we're done, people like to write this with U's and V's, okay? They love to use U's and V's for this. Now, this is derivative M, right?
Mm-hmm.
Okay, well, what if we integrated everything? And you integrate this right here. All right.
So the G prime will become G,
All right.
and F prime will become F, original
It's the
function.
same thing.
Integration, right?
Same thing, except with the F used.
Hold on, let him think,
It's
let
the
him
same
think.
thing.
Mhm. And then when this was the derivative of an F times G, right?
Uh-huh.
So, if I call this, let's see here. I wanna make sure we prove it. Cause I want you to change it to U's and V's. Maybe I should use, before I show you this, this be. Hold up, I wanna the right letters.
Okay.
Give me a sec. You'll like this too. I'm telling you, it'll only take you like 5 minutes. The reason I wanted to show you the proof, because the proof kind of is cool, it's fast. You know, a lot of math proofs are what? Tough,
Yeah, yeah.
sometimes impossible.
When do you do these things, like prove by induction and all this? That's like for discrete?
Yep. There we go. And what's the derivative? So I think it helps when you write f of x and you write g of x. And what's the derivative by product rule of an f of x times a g of x?
So f(x) times g prime of x
Okay?
plus g of x times f prime of x.
Rock and roll. Awesome, everyone good?
Uh-huh.
Now, we're gonna prove this. We're gonna come up with a technique for doing the opposite of product rule. So let's integrate both sides of the equation. Well, the good news is, guess what happens when you integrate a d dx?
So f becomes fx gx.
The good news is, when you do this with this, what happens to it?
It comes to the original equation.
You know, it's like square root something squared. It just does what here?
Original equation.
So this just becomes what?
fx gx.
Coming back to you. All right, now, unfortunately, these both get integrals. So you get an integral of f of x, g, prime of x, plus an integral of what?
I see it right now.
He sees it.
So basically it will be
Right.
g of x with integration of fx
Yep,
plus f of x integration of g of x,
yep.
right?
And then if you want, you can call this dx here, if you want to think of these with like dx's, right? Because then they always put the dx there.
Uh-huh.
But now, what we're gonna do is, we're gonna write this so we get this isolated. So I need this off this side.
Okay.
So right now we have this, let me write it again.
Uh-huh.
All right. I just wanted you to see the proof.